In this video, we're going to be looking at how to plot graph in Waec Alternative to Physics Practical. Here we have a setup for electricity, and we are just going to read through the setup. But before that, do ensure to like, subscribe, and share this video for other viewers who are looking for solutions or ways to learn how to carry out alternative physics practical for GCE so that they can see this video. So without much ado, let's just quickly run through the instruction to be carried out. So a circuit is connected as shown in the diagram above with the length S of the Constantan wire connected. The key is closed such that the current passes in the circuit. So this is the circuit. We have an EMF source, that is a battery, a switch, an ammeter, a voltmeter is connected in parallel across the Constantan wire. So this is the Constantan wire of length AB. So let's look through the procedure. The current I in the circuit is measured and recorded. So we're going to use the ammeter to measure that all. The current is measured with the ammeter. Also, the corresponding potential difference V across the Constantan wire is measured and recorded. So the voltmeter is used to measure the voltage drop across the Constantan wire. So the procedure is repeated for 4 other values of S to obtain the corresponding values of I and V, that is the current and the voltage. Figure 3a shows the values of I sub I, while figure 3b shows the corresponding values of V sub I. I'm going to show you the diagram in a short while. Okay, so these are the diagrams. So this shows the readings on the ammeter, and this shows the readings on the voltmeter. And figure 3c shows the values of Xi, where I equals 1, 2, 3, 4, and 5. So the sub I means that the values of X for different length of the wire. So you're going to take a look at the measurement for X. So this here is to take the measurement for S, and we have a scale given for X, so we're going to use the scale. So let's go back and read through the question. So we are to measure and record the values of S sub I. So from the diagram, we're going to measure the values of S sub I. We're going to measure the raw values and then we get the converted values. Okay, so let's just read through that. We'll come back to this place and take all those measurements. Read and record the values of I sub I. Also read and record the corresponding values of V sub I. In each case, we have to evaluate Q equals V over I, V squared, and P is equal to V squared over Q. We have to tabulate our readings and plot a graph of P on the vertical axis and S on the horizontal axis. We have to determine the slope of the graph. Then from the graph, we use your graph to determine the values of S for which P is maximum. Okay, we get that from the graph. Then state 2 precautions that are necessary to ensure accurate results when performing this experiment. What happens to the resistance of a lamp as the current through it increases? These are just theory questions to answer. So what we'll be concerned is how to determine the readings from this. So I'll just move to the next slide and we'll look at how to get these readings. So for this, we can easily get the readings from here. And for this, we need to understand that the readings I will get from here may not reflect the actual readings that it will be on the paper. But the idea of this video is just to show you how to determine or how you carry out the measurement. These are not printed documents, but they are downloaded from the internet, so there may be distortion to the actual length of this. But the whole idea is to get understand how to carry out this experiment. Okay, without much ado, let's get the readings for the current. Okay, So what you're going to do here, you see a composite table here, because according to the instruction, we have to get the raw values of S. Okay, we have to get the raw values of S. So in this my table, I need to add a value for the converted values of S. So I need to add that now. Pardon me. So I just have to add that now. Okay, so I have adjusted that now. Now you'll see a composite table here. I've already drawn the table to make my work very easy, to make the video a short one. So you have the raw values of X, then the converted value. The reason why I'm having the converted values of S is because of the scale that we're given here. Then on this column here, we also have the values of the current I that we are toward measured in amp. Then we have the voltage. Then we have Q is equal to V over I, which is we are told to evaluate from the question. Then we have V squared that we're asked to evaluate, and the unit given in volt squared also. And the units of all of these are included. So you see that I have a unit for this. I actually derived the unit for this by using the parameters that we have here. So P is equal to, so I can easily quickly show you how to get that, how to derive the unit. It is very important to always include the unit. So P, because we are given that P is equals to V squared all over Q, and you know that V squared is measured in volts, so that will be volt square divided by, and here Q is actually V over I, so that's V over I. So when I work this out, that is going to give me V squared times I over V. Okay, so when we work this out, you're going to get this will cancel out this, so we'll have this. So the unit should be volt ampere. So what I'm going to do, I'll just take my ruler and place it the 0 mark on top of this. I'll take all the raw measurements. So my raw measurement for this, my X is 2.0. So you have to take all your reading to at least 2 decimal places for direct reading. So I'm going to write this 2.00. I said at least 2.2 decimal places. So this is going to be 3.5, 0.6, 0.7, 3.9. So this is 3.90. Then the next one, I'm going to S3. So this is 5, 5.5, 0.6, 0.7. So this is 5.70. Then the next one, X4. This is 7, 7.1, 0.2, 0.3, 0.4. So I have 7.40. And the next one, X5, is 9.12. So that's 9.20. So I have to convert all of this to the given scale, using the given scale. So the converted values will be times 10. So I have to multiply all of this by times 10. So this is going to be 20.00 to 2 decimal places, at least 1 decimal place. So this is going to be 39.00. This is going to be 57.00. This is going to be 74.00. This is going to be 92.00. Then for the current, we can read the current from here. So first of all, what you have to do is to look at the division between the readings. So this is 0 and this is 1. Just count the number of small lines between the 0 and 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divide 1 by 10. That's going to be 0.1. So it means that each of these division here is 0.1. So on this, that's going to be 0.0.2 for I5. So you can see I5 read on that 0.2. So I'm going to record that 0.20 to 2 decimal places. So this is I4. So you count this. So when you count this, you're going to have up to 4. So that will be 0.40. Then for I3, this is 1, 2, 3, 4, 5, 6. So that's 0.60. Then for I2, this is 0.70. And for I1, it's directly on 1, so that will be 1.00. So we're going to read the voltage also. So from here, you do the same for the division. So the division is going to be 0, 1. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 divided by 10 is 0.1. So it means that each of the division is also 1.0. So this is going to be 1.1. 0. I'll take it to 2 decimal places. So this is going to be 1.1, 2, 3, 4, 4, 5, 6. 1.60. Then the next one is exactly on 2. So that'll be 2.00. Then this is on 2.1, 2.2, 2.3, 2.40. Then finally, V5 is on 2.85. So this is 2.5, 0.6, 0.7, 0.8, in between the 2.85. So we evaluate Q. Q is equal to V divided by I. So we are going to divide this by this, and that's going to give us 1.10. I'm going to take this to at least 2 decimal places again. And I'll divide 1.60 by 0.70. That's going to give me 2.29 to 2 decimal places. Then I'm going to divide 2.00 by 0.60. That's going to give me 3.333. So I'll take that to 2 decimal places. Then I'll take 2.40 divided by 0.40. That's going to give me 6.00. Then 2.85 divided by 0.20. That's going to give me 14.25. And next, we have to evaluate V square. So we're going to square all of this and give the result to at least 3 significant figures. So when I square 1.10 square, that's going to give me 1.1, which is 1.21. Three significant figure. So when I square 1.60, I'm going to get 2.56 to 3 significant figure. When I square 2.00 square, that's going to give me 4.00. And when I square 2.40, that's going to give me 5.76. That's going to give me 5.76. So I'll take that to 2 significant figure. Then when I squared 2.85, that's going to give me 8.1225. So we'll take that to 8.12. So we are going to evaluate P is equal to V squared divided by Q. So we're going to divide this by this. So when I divide this, that's going to give me 1.10 to 2 decimal places. So this, we are taking this to at least 3 significant figures also. We are evaluating this to at least 3 significant figures. So when I divide 2.56 by 2.29, I will get 1.12. When I divide 4.00 by 3.33, I will get 1.201. So I'll approximate that to 1.20 to 3 significant figures. And I will divide 5.76 by 6.00. I'll get 0.96. So that will give us 0.960 to 3 significant figure. Then when I divide 8.12 by 2. When I divide 8.12 by 14.25, that's going to give me 0.5698. So I'll approximate that to 0.570. So this is the composite table. So here I'm going to end this here. So you watch out for the graph in the next video.